go to 31. And I know right now you're like, what is that, right? That sounds scary. It's not that scary. Normal CDF, inverse norm. I will just highlight this part here. Use these when the values do not appear on the graph. Page 32 this is. We're going to 32. So we go press second vars, and then you choose normal CDF. So let's do that real quick. Where did I leave my calculator? I just had it here. Oh, I'm covering it up. Quit. So yeah, you just go second, and then vars. Vars is right here. Can I just, because some of you might forget, exam times like, oh, I don't know where to find it. Look at the distribution. See that? It says distribution. So think of normal distribution. Maybe that'll help you, but you got to go second vars, and then you will either pick normal CDF or inverse norm. Those are the only two we're going to use in this course. Normal CDF and inverse norm. Okay. What does normal CDF need? It needs a lower limit, upper limit, mean, standard deviation. This is going to be standard, mean standard deviation at the end. What does it do? It will calculate the probability of data points existing between those two values. The answer is given as a decimal. Answer is a decimal, so we multiply it by 100 to get a percentage. Okay. Normal CDF needs 4 entries separated by a comma. That is probably one of the things that you need to make sure it has those 4 entries. So if I were you, on my study sheet, I would actually have normal CDF, like basically how do I get there, right? Second vars, normal CDF, what does it do and what does it need? What does it do? What does it need? It gives you the probability under the curve, right? Because remember, those percentages are probabilities, like the likelihood of something being within two values. Lower limit, upper limit, mean standard deviation. The lower limit is the value that would be to the left of the curve. Upper limit is to the right side of the curve. Remember that if z-scores are given, I'm going to highlight that as well. If you get z-scores, what do you know about z-scores? That the mean is 0 and the standard deviation is 1. Okay, so basically the last two numbers here would just be 0, 1. So z-scores are very important because they don't need to give you the mean and the standard deviation. You just know, hey, I know that this is true about z-scores. Okay. Assume the mean income per household in a city is 45,000 with a standard deviation of 15,000. Right? So there's your mean and there's your standard deviation. What percentage of households earn between 30,000 and 65,000? I took the liberty to make that normal curve for you already. Okay. Do you see 32,000? Do you see these two values anywhere down here? Because this is what you would graph, right? 45, this is my mean. And my standard deviation goes up by 15,000, right? Goes down by 15,000. So this is the normal curve, okay? Normal curve. That represents a scenario, but these values are not on there, so you can't use it, okay? Asking for percentage. You should know right away this is a normal CDF scenario. And I want you to show this as part of your work. Okay, normal CDF, and then you enter the values that it requires. In this case, 32,000 is my lowest. It's my lower limit. 65,000 is my upper limit. What else does it need? Mean, standard deviation. So my mean is 45,000. My standard deviation is 15,000. All you have to do is this, okay? This is low, upper, mean, standard deviation, right? In that order. Order does matter here. So let's go ahead and do that. I'm gonna quit everything and I'm gonna go second vars, normal CDF, 32,000, 65,000, and then mean and standard deviation. Close the bracket, hit enter, and you get 0.7157 and something. If you multiply this by 100, so whatever's on your screen, you either shift the decimal 2 spaces or you just multiply it by 100, you get 71.57% of households. Earn between 32,000 and 65,000. That's what you've determined based on the information that you've given, that you've been provided with. Okay. I will say this, we're also assuming that it's normally distributed, right? Because not all data in life is normally distributed. Just remember that, okay? Oh, everything is a bell curve, not always. Sometimes I mark your test and I actually have, I can click on the graph, and sometimes it doesn't look at all like a normal curve. Sometimes it looks like a W, like you've got like a boom and like another boom. Like it doesn't always look normally distributed, okay? But we know that a lot of times data is normally distributed, and that's when we can apply this reasoning right here, okay? So when you want to, I don't know, I'm going to go pink and green maybe, but right, your lower limit has been given and your upper has also been given. So those are the easiest scenarios when you know the upper and the lower. Okay. So where is 32,000 approximately? I would say 32,000 would be right about there. Okay. And 65,000, if you go along the curve here, it's probably right about there. Okay. So we just found this, the percentage that would fall under that, right, low and upper. We found the percentage of households that would fall under this. That's what normal CDF does. Okay. Next. What percentage of households earn more than 75,000? More than 75,000. So there is no upper and lower, is there? So basically what it's saying that it's 75,000 is your low and upper is, what is the upper? There is no upper. What's going on here? Like, because normal CDF needs both. So what I will tell you is just put a really big number in there. So we're gonna just go really like far out to the right as far as you can, and just make sure you include all the households that are far right. So I'm gonna say if this is 75,000, I'm gonna go 1 million. Okay, just add a bunch of zeros. If you want to add more zeros, that's okay. Okay, so that's what is happening here. So if this is our low, 75,000, right? If this is our low here, let's come over to our right here. 75 is right there. So we want everything over here. So from here on, everything that way, we want to know what this is. Okay. Oh, 75,000 is on here. I didn't mean to do that, but it's on. We actually, this value is here. So we know it's 2.35 plus 0.15, so it's approximately 2.5. Here's the shocking news. These numbers are approximately. The calculator finds out exactly. So it might be slightly off. So here we go. Normal CDF. You gotta plug in everything. So 75,000. Then you go 1 million. Then you still gotta enter the mean and the standard deviation. Okay, that doesn't change. So let's figure that out. I just copy paste. Once I've used normal CDF, I just go up, I copy paste, especially because the mean and the standard deviation haven't changed. Oh, you might have to change it, sorry, because we got to put in that 1 million, right? But our low is 75,000, so I can just leave it like that. Our upper is 1 followed by 6 zeros. So that's where the problem. So we have to retype the last little bit. So 45,000 and 15,000. Close the bracket. Hit enter. Hey, I just went 100,000, sorry. Come on. I thought I typed a million. Okay. And let's try this again. There we go. So you get 0.0227, and that keeps going. You multiply that by 100, and that's 2.28%. You can round to 2 decimals at the end. And you might say, well, isn't it 2.5, right? As I said, these numbers are just to estimate, to go approximately. Okay, they're not exact. So when I ask you, usually I won't put a number that's already on this graph. I won't use that to ask you to use normal CDF. Okay, what about this one? What percentage of households earn less than 39,000? So in this case, 39,000 is your upper, but what about the lower? Okay, what's up here? What's up with that? Okay, what do I put there? And this is what you do. You go normal CDF, and you just put in a very low number. Okay, and you might say, is 0 good enough, Mr. Dirksen? Is 0 good enough? I would go even lower than that, because 0 is actually part of my graph here. So I don't know, you can go minus, a negative 50,000. I know it doesn't seem to make sense, but just make sure you include everything to the left. Okay, so negative 50,000 all the way up to 39,000. And then you plug in your mean and your standard deviation, like that. So let's enter that. I'm just going to go call it again, because I don't like to write over existing numbers. So I'm going to go negative 50,000. Can I go negative a million? Yes, you can if you want. Just go as like exaggerate a little bit. 35,000 and followed by 15,000. Okay, you get that? 0.3445 and something. You multiply that by 100, you get 34.46% of households earn less than 39,000. And the upper, I usually go pink, right? 39,000 would be somewhere in there. Okay, so we're actually, go ahead. We're actually interested in everything under the curve that is to the left of that. Okay, so you got to kind of put up a lower limit on that one. So sometimes it gives you the upper and the lower. Sometimes you need to come up with an upper or a lower, depending on the context. Okay, it depends on the context. Let's keep going. Okay. This is inverse norm. This is inverse norm. So let's go look at page 33. So again, you need to press second bars for this, right, on page 33. And there we have inverse norm. What does it need? Percentage of data below. It needs to have the mean and the standard deviation. Okay. I have to make sure you understand. Make sure you copy this down as a decimal. Okay. If you don't get that as a decimal, you have to turn your percentages to a decimal. So you have to divide by 100. What will it do? It will calculate the actual value along the x-axis you're looking for. So it could be height in centimeters, weight in pounds, number of days, etc. So when will you be using inverse norm? When you're trying to find an actual value, not percentages. Okay. Just before we jump in and use this, I want you to remember that if 35% of people earn more than 50,000 a year, then, right, if the 35 here make more than this, that tells you that it's 35 there. Okay, which means how many are below? Because that's what we're always interested in. Below 50,000. That is the question. So if it's always 100% for the entire curve, okay? It's 100%. So if this is 35, we just go 100 minus 35, okay? So we know that this is 65%. This is what inverse norm always wants, the percentage to the left, okay? Or earn less. Same thing here. One more thing. You're with me, right? I know it's basically Monday. I know that. Can I also tell you that if 35% are above you, that means that you're higher up on the curve. Because 50% would be right in the middle. If 50% make more than you, you would be right here. If 35% make more than you, then you naturally have to think of, okay, then I'm higher up because, right, there's fewer to the right of me. Okay, so let's do this one. If 42% of students spend less than 15 minutes on homework, then, okay, 42% of students spend less. This would be 50%, so 50 would be less, 50 would be making more. Since there's 42% below me or below the 15-minute mark, this is where I'm kind of looking at. This is the 15-minute mark. And I know that 42% land right in there, spend less than 15 minutes on homework, right? So you have to think of shorter or spend less. That would always be to the left. And then write more or spend more time or longer, spend longer homework would be to the right. So again, why didn't I put it in the middle? Because that would have meant that there's 50 below, 50 above. It's at 42% spend less, so I'm kind of slightly shifting to the left. This is just to estimate. This is not like a very accurate sketch, but this is sort of what's happening here. And so that's what you would want. This is what you would want. That's what inverse norm is looking for. The percentage to the left or below. Okay? Let's keep going. Let's use this. Example. This income, so they're asking, it's like, what's that income that would have 30% of household earning less? 30% of household earning less. Where would you make that line? I would say it goes over here somewhere. Because if, right, 30% earn less, we are not really concerned about it, but what would be under this side of the curve? What percentage would be over here? 70, right? But we don't care about it because inverse norm just cares about the percentage to the left. So what we're trying to find is, what is this? Like, what value would go along the x-axis here for you to have 30% earning less? Okay, so let's try that. We're still talking about the previous page, okay? Can I just say that here? The mean is still 45,000 and the standard deviation is still 15,000. Okay, that's still, this is page 32. So you're not wondering, like, where did you get the mean and the standard deviation from? So we would go inverse norm. Okay. You would have to say, okay, I know it's 30%, but I'm going to put 0.30 or 0.3 in here. And then I have to follow it with 45,000 and 15,000. Let's see what we get. So you got to go second vars, inverse norm, 0.3, followed by 45,000 and 15,000. And there it is. Remember, we're talking dollars in this particular case, right? Earning money. Okay. So if 37,133.99, right, is the income where 30% earn less. Okay, so that's the income. This is the 37,133.99 that we've determined based on inverse norm that would have 30% of families earning less. So the government might say, we want to help like the families that are the bottom 30% of income. So they might have a policy that says anybody earning less than 37,133 will get some kind of benefit paid out to them. How would they know that? Well, they've done the math, right? They're like, okay, well, we've determined that based on normal distribution, that's the amount we're kind of targeting. Anybody making this much or less, that would service 30% of our population. Right? So it goes that way. Okay. Let's try another one. An income of dollar, right? An income of this would place a household on the top 20% of household incomes. And this is some key wording here. Top 20%. That should tell you it's not bottom 20, it's the top 20. So we're thinking, if you're thinking top 20, then you're definitely not in the middle because that'd be 50-50. So top 20 would be somewhere in here where you have the 20% right there. They gave you the percentage to the right of the curve or of that value or making more. You want this one right here. Okay, right? This is 80%. This is what you want. That's what inverse norm wants. So that would be the extra step you would have to take here. So inverse norm is 0.8 or 80%, right? Mean followed by the standard deviation. Only time inverse norm will be an actual percentage is if we're talking about like test scores, right? If it's like what test score would you have to have, then yeah, these would all be percentages that you're entering here. The mean, like let's say 65 for the test, and there's a standard deviation of 5%, right? So whatever this is, those would be the units that you want to be using. Okay, this is a dollar amount, this is a dollar amount. So these units, right, tell you what your answer is going to be in. Okay, so let's do the math here. This one I can copy paste. I'm not going to have to change a whole lot. I'm just going to change that one to 8 and everything else stays the same. So 57,624 and 32. So inverse norm gives you that. So you could say 80% of households earn less than 57,624.32. But at the same time, you could say that this income also, right, has 20% of families earning more. So you can put this 57,624.32 at the top there. So you can see it both ways. 20% make more, 80% make less. Inverse norm is focused more on percentage earning less, or percentage that are shorter, or percentage that weigh less, or what have you. Okay, that's what inverse norm is interested in. I want you to try C. I need a break. Once I'm going to drink some water. Try C. Would you be able to answer that one? This one, I would argue, is very close to the center, right? This is the 50 line, so 45 would be right about here. This is just to help you out. So if this is 45, then we know this is 55%, because it's always 100% under the curve, remember that. This is what inverse norm wants. So inverse norm, 0.55, and then 45,000, 15,000. You get, just added this slide. I'm just going to retype it. That's 46,884.92. So that's the income we're after, right? 46,884.92. Can I just add something to this? Because I know you'll come. Never mind, I won't add anything. I'm going to ask you to try pages 34. I'm not going to assign all of the work that I normally do. So let's just go 34 to 36. It involves you graphing the curve, but you will notice that you'll have to use normal CDF or inverse norm to actually answer. Okay, so make sure you practice, because I want you to get to the point where you're like, I'm stuck on this one, so I can get you unstuck and then clarify things. All right.